September session. The first question in September session, the first question is f of x is equal to oh, it's very good question. It takes some time. A e power x plus b e power minus x, and it is c x square and ax square plus 2cx, and it is from minus 1 is less than or equal to x less than 1, 1 less than or equal to x less than or equal to 3, and it is 3 less than x less than or equal to 4. And f dash of 0 plus f dash of 2 is equal to e, then the value of a is equal to, you see this question, this is one of the best question, I think so. If you have an idea about coordinate, that is continuity and differentiability, then it will be very easy to do this problem. Okay, now moving to the next question. You see that question, just wait a while. Okay, let us see. So first, because it is differentiable, whenever the function is differentiable, it must be continuous. So I am going to check continuity, that is 1 plus and 1 minus. What about 1 plus? 1 plus means this function, that is c x square. Now substituting 1, we will get c is equal to 1 minus. What about 1 minus? This is the function. You substitute 1 here, a into e power 1 plus b into e power minus 1. So that is nothing but ae plus b by e is equal to c. Now ae square plus b is equal to c. Is it clear? Now okay, next at 3 plus and 3 minus, because it is differentiable, it is continuous only. So 3 plus value, what about the 3 plus value? This is the function. 3 plus, this will be the function. Substitute 3, 9a and 6c is equal to 3 minus. What about 3 minus function? Cx square. X square means 3 square, 9. That is 9c. So from this we can find 3c is equal to 9a. Am I right? And that is c is equal to 3a. Now we have c is equal to 3a. C is equal to 3a. Okay? Now differentiability, I am going to check differentiability. Now 1 plus, okay, is it clear? Now 1 plus, so we have two conditions. Next 1 plus, what about the 1 plus function? Cx square, this is the function. So what about its derivative? 2cx, but x is equal to 1, so we have 2c. 1 minus means this is the function. So what about its derivative? A e power x minus b e power minus x. So while substituting x is equal to 1, you will get a e minus b e power minus 1. Okay. So we have 2c is equal to ae minus b by e. Now 3 plus, what about the function? 3 plus, this is the function. So what about its derivative? 2ax and so we have a relation. So there is no necessity to write all these, just we can. So you see that question, f dash of 0 plus f dash of 2. F dash of 0 plus f dash of 2 is equal to e. F dash of 0 means in between minus 1 to 1. So you differentiate this one. A e power 0 minus b e power minus 0 plus f dash of 2. 2 is in between this function. So this is cx square. What about its derivative? 2cx. X means 2 is equal to e. So this is a minus b plus 4c is equal to e. So a means a, because we are going to find the value of a only. Now convert b. B is equal to, what we can write here? B is equal to CE minus AE square. But C is equal to 3A. So 3AE minus AE square. So B can be written as 3AE minus of minus plus AE square plus 4c, c means 3a, now it is 12a is equal to e. So we have 13a minus 3ae plus ae square is equal to e. So you take a common, so 13 minus 3e plus e square is equal to e. Now a is equal to e by 13 minus 3e square, 3e plus e square. So this is the solution for this question. Okay, is it clear? Now let us move to the next question. This is the 2020 September question, first phase, I think so. Question paper. This is the first session, second morning session question paper. Okay. Is there any question in continuity? I marked the questions numbers. No, there is no question. And next go to the fourth and second evening and third morning, third evening, there is no question in continuity and differentiability. Now fourth morning question. Yes, this is the question where f of x plus y is equal to f of x plus f of y plus x y square plus x square y, and limit as x tends to 0, f of x by x is equal to 1, then what about f dash of 3? This is one of the important method to find f dash x. So what about f dash x? Limit as h tends to 0, f of x plus h minus f of x by h. This is the basic definition of differentiation by using first principle or from the definition. Now limit as h tends to 0. What is f of x plus h? F of x plus y is equal to this one. So replace y with h. You will get f of x plus f of h plus x h square plus x square h. This is all f of x plus h minus f of x by, that is h. So f of x will be the cancel. Next limit as h tends to 0, f of h by h, you separate that one, and plus h cancel, limit as h tends to 0, xh, limit as h tends to 0, hh cancel, x square. This value f of x by x is equal to 1, that is also 1, plus if h is equal to 0 it becomes 0, plus it becomes there is no h at all, so x square. So that is 1 plus x square. So this is all equal to f dash of x. Now f dash of x is equal to 1 plus x square. What we have to find? F dash of 3. Now the answer is 1 plus 3 square. It is just nothing but 10. Okay. Now let us move to the next question. So this is the only question that was given in fourth morning, and let us go for the next question, that is in the 4th September evening batch question. That is f of x is equal to pi by 4 plus tan inverse x, where mod x less than or equal to 1, and 1 by 2 of mod x minus 1 when mod x less than greater than 1, mod x greater than 1. Okay. So what we have to find is continuous, where it is continuous and where it is not differentiable. Okay. So it's a good question. First you have to verify what is meant by this one. This is nothing but minus infinity to minus 1 including, and 1 to infinite. And here we have two cases. Mod x greater than 1 means in between minus 1 is less than x less than 1, because mod x takes minus when it is in negative side, mod x takes positive when it is greater than 0. So I am going to write this one as in between minus 1 to 0, mod x is negative, so minus x minus 1 by 2, this is minus x minus 1, so taking minus as common, minus of x plus 1 by 2. So, and again we have one more interval, that is 0 to 1, so 0 to 1, so 0 to 1 means it is positive, so x minus 1 by 2. Okay, so there is no necessity to write this one. So this is the function. These are the three cases. Am I right? So this is the case. Now you see, x tends to minus 1 plus, and greater than minus 1. Greater than minus 1 means minus 1 to 0. What about the function is minus of x plus 1 by 2. Okay. So what about its value? Minus of x means minus 1 plus 1 by 2. So it is 0. Is it clear? Now x tends to minus 1 minus, less than minus 1. The function is this one. That is pi by 4 plus tan inverse of x. X can be replaced with minus 1. So that is pi by 4 tan inverse minus 1 minus pi by 4, it is 0. So it is continuous at x is equal to minus 1. Now you check whenever it is continuous, you can check for a differentiability. Now what about its derivative? Minus x minus 1 by 2. The derivative is nothing but minus 1 by 2. Okay. Now what about minus 1 minus means this is the function. What about its derivative? 1 by 1 plus x square. But x is equal to minus 1. You will get 1 by 2. This is not differentiable because these two values are not equal. But it is continuous but not differentiable at x is equal to minus 1. Okay. It is continuous but not differentiable. Okay. Let us move for the test. One more test for at 1. Suppose 1 plus. 1 plus means this is the function. Pi by 4 plus tan inverse of 1. That is pi by 4 plus pi by 4. That is pi by 2. Now 1 minus. What about 1 minus means less than 1. This will be the function. X minus 1 by 2, 1 minus 1 by 2, 0. So this is not continuous because you are getting two different values. It is not continuous, which is discontinuous at x is equal to 1. Whenever it is discontinuous, it is not also not differentiable. So discontinuous at x is equal to 1 and continuous at x is equal to 1. Okay, continuous x is equal to minus 1. Sorry. So we can conclude that continuous at x is equal to minus 1 and discontinuous at x is equal to 1, but not differentiable at these 2 points. At x is equal to minus 1 and 1. At these 2 points it is not differentiable because at first x tends to minus 1, it is continuous but not differentiable, and here at x is equal to 1 it is not continuous, which means it is not differentiable. So differentiable at not differentiable at 2 points and continuous at 1 point and discontinuous at 1 point. So that is the solution for that question. Okay. Next, coming to the next question. Is there any question given in that session? 4th evening? No. Now coming to the next paper, that is on 5th September. You see the second question. I think it is 4th question. I think so. F of x is equal to k of k1 of x minus pi whole square minus 1 x less than or equal to pi and k2 of cos x greater than pi. It is twice differentiable and we can differentiate 2 times. Then what about the values of k1, k2? Okay, it is differentiable means it is continuous. Okay, you remember that one. It is continuous. Continuous means the pi plus value is equal to pi minus value. Pi plus means k2 cos pi is equal to x tends to pi minus. Pi minus means this is the value k1 of pi minus pi whole square minus 1. Cos pi means minus 1. So it is minus k2. It will be 0 minus 1. Now from this we have k2 is equal to 1. Whenever a function is differentiable, it must be continuous. So by using the continuous process, we will get the value of k2 is equal to 1. Now differentiate. What about the function pi plus? Pi plus, the function is k2 cos x. Now we differentiate 2 times, minus k2 sin x and minus k2 cos x. Okay, this is given function f of x, f dash x, f double dash. Okay, while substituting pi, what we will get here? Minus k by k2, cos pi means minus 1. So it is nothing but k2. Now you see this function x tends to pi minus. This is the function. What about function? k1 of x minus pi whole square minus 1. This is f of x. What about its derivative? k1 of 2 into x minus pi. Its derivative is 0. Next, again this is f dash x. What about its another This is 2k1x. What about its derivative? 2k1. Okay. These two are equal because it is differentiable, twice differentiable. So we have k2 is equal to 2k1. But what is k2? K2 is nothing but 1. 1 is equal to 2k1. K1 is equal to 1 by 2. So we have k1 is equal to 1 by 2 and k2 is nothing but 1. So these are the two values for k1 and k2. Okay. Next, it's a very easy topic. Continuity and differentiability is very easy topic. If you have an idea about continuity and discontinuity, differentiability, so it will be very easy. And is there any question is given in this session? Another question? Yeah, one more question is there. That is the last question in 5th September. 5th question. F of x is equal to x into step of x by 2 for minus 10 is less than x less than 10. Where step denotes the greater integer function, then the number of points of discontinuity is equal to number of points of discontinuity. Okay, I told number of times whenever step function is given, it is always discontinuous at all x is equal to integers. Except integer only it is continuous. Okay, I think you have to know very well. What about the graph of step x? It will be like this. So it is discontinuous at all integers. So here are the integers are minus 2 to 10, but it is x by 2. So minus 5 is less than x by 2 less than 5. Okay. So in between minus 5 to 5, not include the values both. In between minus 5 to 5, we have minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. These are the 9 values. At all integers, it is discontinuous, obviously. But you see here is x is there. Whenever x is there, x into, at 0 you see 0 plus. 0 plus means x into 0, that is x, while you substitute you will get 0. 0 minus x into 0 minus means negative of, that is minus 1 minus x, but it is 0. So it is continuous because outside we have x, a function is there, x into step of x by 2. So at x is equal to 0, it is continuous, not discontinuous. 0 into some value, 0 into some value, see here. So it is continuous at x is equal to 0. So we have remaining 4 and this is 4 values. Total we are having 8 values. At these 8 values, the function is discontinuous. Okay. Now let us move to the next question. This is 6th September. Limits question. 6th question. Now let's see this question. 6th question. Limit as x tends to 1. Integral, of course it is question from definite integration, we can say x minus 1 whole square t into cos of t square dt by x minus 1 into sin of x minus 1 dt. Here is dt. Then it is a. Okay. You see this question, L hospital, just because if you substitute x is equal to 1, will you get the denominator 0. Now what about the numerator derivative? 2 of x minus 1, derivative of this one, and you substitute here x minus 1 whole square into cos of x minus 1 whole square minus lower limit derivative is 0, there is no necessity to write, but we have, denominator we have to use UV formula, x minus 1 into cos of x minus 1 plus sin of x minus 1 into x minus 1 derivative is 1. Okay, is it clear? Now you see this is sin of x minus 1. Now you can write x minus 1 into x minus 1. So this value is equal to 1. Now you can take x minus 1 as common in the denominator. X minus 1 as common in the denominator. So you take x minus 1. So you will get 1 only. So x minus 1 cancel. Now you apply x is equal to 1. If x is equal to 1, numerator will be 0 and denominator will be 1 minus 1, 0. Cos 0 is equal to 1, 1 plus 1, 0 by 2. Now the answer is 0. Okay. Now, is there any more? Any questions are there in this paper again? Oh, yeah, one more question is there in this session. Now you see the 7th question, that is, f of x is equal to x to the power of 5 sine of 1 by x plus 5x square x to the power of 5 cos of 1 by x plus lambda x square. This is and one more value 0 is there. X less than 0, x is equal to 0, x greater than 0. Then f double dash 0 exists. Then what is the value of lambda? Okay, f double dash 0 exists. So f double dash 0 exists means the function differentiable. Differentiable means it is continuous. So there is no necessity to check continuity here. We have to find the lambda value. Okay, let us see. 2 times differentiation. While differentiating this one, you will get always 0. I will explain this question. Suppose we have to differentiate this one. X power 5 into sine derivative is cos and 1 by x derivative minus 1 by x square plus sine of 1 by x into what is the derivative of x power 5? 5x power 4. I will explain this derivative. Just you see up to here only. Okay. Now you see x cube, that is minus x cube into cos of 1 by x plus 5x power 4 into sine of 1 by x. At x is equal to 0, what happens? Either 0 plus or minus. The answer will be 0 only. Remember this question. It is differentiable. Somebody says that if x is equal to 0, this will be not defined. Cos of infinite. Cos of infinite exists because the cos x domain or sin x, you see the graph of sin x or cos x will be like this. Of course, cos x graph will be like this, but the value in between minus 1 to 1. So cos x domain is r. So cos infinite exists. It's a finite value in between minus 1 to 1. So because x is equal to 0, 0 into finite value it becomes 0 only. Okay. So there is no necessity to write this one because at x is equal to 0, differentiation will be 0. This one or this one. Okay. Now if you know this concept, this problem will be just within 5 seconds. What about the derivative of this one? 2 times 10x 10. What about the derivative of this one? 2 lambda x 2 lambda. 2 times differentiation because these two are equal. Why? F double dash 0. So this is equal to lambda is equal to 5 because the previous this function is 0. When x is equal to 0, this all becomes 0. After 2 times differentiation you will get a 10. After 2 times differentiation here you will get a 2 lambda only. Okay. So it is differentiable. So equate these two, you will get lambda is equal to 5. It's a simple solution. And coming to the last paper, that is an 6th September evening question. Yeah, one more question, simple question. I think I explained previously this question. It's a differentiability question. You see, this is the last problem. 2020 September batch question. That is 8th question. F of x is equal to maximum of x comma x square whenever it is not differentiable, just by using graph. One is y is equal to x, other one is y is equal to x square. So y is equal to x means it is a straight line like this, and y is equal to x square means like this. Okay, and this is the point and these are the 2 points of intersection. We have to write the maximum of this one. So you see, from minus infinity to 0, this curve is maximum. So this is maximum. And you see, from here onwards, straight line occupies more area. That is, the curve is upper curve, y is equal to x. So from 0 to 1 only, this point, this is 1. Why you can say this is 1? Equate these two. 1 minus x is equal to 0 comma 1. These are the 2 points of intersection of the given 2 curves. Okay. So, and after 1, you see the curve is above than the line. Now, and here it is a curve. So it is a sharp edge and it is also sharp edge. Suddenly it takes changes its direction. So we can call it as a sharp edge. The curve takes sharp edge and again it takes another edge. So at these 2 points, x is equal to 0 and x is equal to 1, it is not differentiable, okay? But it is continuous everywhere. The graph moves continuously without having any break. So these are the questions that was given in 2020 January and September session, okay? I posted one more video on previous JEE questions in April 19, include that one, 15 the best questions in continuity and differentiability. You watch that video also. If you have any doubt, you just post your doubt in the comment box, and if you like this video, share to your friends, and tell your friends to subscribe this my channel. Okay, right, thank you.